Oops, no. Right. Just cancel that. So let's talk about files. Now, when you come to do some real world programming, particularly when you're doing some modeling, for example, we're often going to want to read in data from files and output our data as files. Because if you think about it, in reality, you're not going to be sitting there writing your model, and then when you give it to the users, asking them to input everything from scratch. You're going to have data stored in files that you want to read in, and that will populate, parameterize your model. And then when the results come out the other side, you want to store that somewhere so you can look at it. And it goes back to, if you remember when we talked in Principles of Programming, about the difference between storing things in RAM, random access memory. So that's stuff like our variables that we're just storing for now while the program runs, versus stuff that we want to store more permanently on our hard drive, for example. Here we've got examples of input data, so stuff that we may want to read in that's stored elsewhere, and also our results, which we may want to then export so that we can look at them and analyze them separately later. And there's different methods for reading and writing files depending on what you need them for. And I'm going to show you a couple of them. I'm going to start with the most pure, the rawest way of doing this. That's probably not going to be the way you do it. Most of the time you would do it in the second method, which I'll show you, because your files will be stored as CSV files mostly, or they should be. So you'll use that. There's also a third method, which I won't show you today, which uses a method in pandas, which basically allows you to read in a file and immediately dump it into a pandas data frame. Now, I'm going to show you this afternoon what a pandas data frame is, but later on in the course, I'll also show you a method which allows you to read in a file straight into a pandas data frame really easily. But I'm not going to cover that today, because I want you to get used to seeing what's happening under the bonnet. And also, if you don't want to use pandas for your particular program, it's not always going to be the case that you use pandas, then these methods will work as well. So let's just think about it in basic terms, first of all. So whenever we read and write files, the first thing we're going to need to do is tell Python to open the file. And we need to do that even if the file doesn't yet exist, which can seem an odd thing to think about. But if you're writing a file, so let's say you want to store some results, and you want to write that to a file, it may be that file doesn't exist yet, but we still need to open it. But we open it in a method to tell it, if that doesn't exist, create a new file with this name. The other really, really, really important thing that I cannot emphasize enough is once we've done whatever we want to do with the file, either reading it in some way or writing to it, then we need to close it. And we must close that file. If you do not do that, you will get all sorts of weird things happening, because your file will be held in a status of being open, and you'll get all sorts of weird file corruptions. It's really important that you close the file. So to open a file, we can simply use the open command. And into the open function, we pass the name of the file we want to open and the method by which we want to open it. And I'll talk more about that in a second. And we're going to store that open file in a variable called f. F now represents that opened file. So we're saying open filename.txt. The R means in read-only mode, so we can't make any changes. We're just going to read it. And then store that file in F. So now, rather than referring to filename.txt as a read-only file, I can just say F whenever I want to say anything about that file. Now, I said R means read-only. There are lots and lots of different modes that you can specify when you open a file. R basically means read-only, but it also means start at the beginning of the file. That's normally what you'll want when you read a file. There are, however, other combinations for read-only. For example, you can use RB, which means read-only, but in binary format. You typically use that when you're reading in image files or video files, but also start at the beginning of the file. You can have R+, which means read and write at the same time, but start at the beginning of the file, etc., etc. I won't go through all these, but do refer back to them. The most common ones you'll use, however, are R for read only, W for write only. So we just want to start writing at the beginning of a file. That also means, so let's say we had a file called filename.txt. And if we open it in W mode, that means if there's anything in there, it'll overwrite it because it's starting from the beginning. If, however, we've got a file and if there's already something there, we want to add to it, so we don't want to remove everything that's already there, we want to add to the bottom of the file, then we do so in append mode, which is the A, which basically means write to the file, but keep everything that's there, start at the end of the file and start from there. So append to the file that's there. So you'll find that you'll certainly use R, W, and A a lot, particularly R and A. Usually you don't want to write a brand new file if you're exporting results. Usually you want to add to it, but there are circumstances where you do, and I'll show you those as well. It's important to say the W and the A modes will create a file if it doesn't exist. So if you give it a file name, that file name doesn't exist, it will create a brand new file with that file name. It won't do that in read mode because obviously you're trying to read a file, and if that file doesn't exist, there's nothing to read. That will throw up an error. So I said it's really important that we close a file once we've finished reading from it or writing to it, or both. Incredibly important you do that. And we simply do that by calling the close method on that file. So if we've opened it and stored it in F is now that file. So we can just say f.close, and that will close our file again. However, a better way, because I can guarantee you, and I speak from personal experience, if you do it this way, you will forget to close the file, and you will scratch your head wondering why your file has gone incredibly corrupted. A better way of doing this, rather than saying, open this file, store it in F, do what we need to do, and then close it, we can use a with statement. And a with statement basically means hold this thing for as long as it takes to do everything in the body of the with statement. Okay, so you'll encounter with statements quite a lot when we come on to SymPy, the discrete event simulation package, where we use it there to say, hold a nurse and keep that nurse until you finish with the patient, and then you can give the nurse back. Here, we're using it for files. We're saying, open that file and keep it open for as long as it takes to do what I specify here. And then we don't need to worry about explicitly closing the file, because as soon as the with statement is completed, it will automatically close the file and drop the file again. So it's a much easier way, because you have to remember to explicitly close the file, and you can see exactly what you're doing with the file being open. So here it's a very similar structure. This time we say with, and then we use the open function. We say open, we give it the file name, we give it the method, the read or write method we want to open, and then we say as F. So when we say with, we give it an alias here to say with that file open, and I'm going to refer to it as F. So with open filename.txt in read-only mode as F, and then within the body, within this tab indented body here, I can say everything I want to do with that file, and I can refer to it as F. And then when I've finished with that file, I simply come out of the indentation here, and it'll automatically drop the file again. So it's a much better way of doing it. Now, it may well be, so by default, if you were to read in a file using a Python read command, it will read the entire file in one go. Well, that might be useful, it might be what you want, but it's usually not what you want to do. Typically, you would probably want to read in a file line by line, and you may want to deal with the things in those lines differently. For example, you might want to store them in different lists, for example. And we can use, on the text file, we can use the read lines function to do that. What that will do, if we say, if we open the file and then we say f.read lines, what it'll do is it will turn a list which represents a list of the lines within that text file. Okay, so here, list of lines, when that's called, when we call read lines, will now store in a list a list of all of the lines of text within our text file. Now, I've talked about text files, and it may be that for some situations you want to use text files, but more commonly, particularly for the sort of stuff that you're going to be doing in terms of modeling and working with the data that you have, you are likely going to want to be using CSV files, comma-separated value files. And particularly because data in spreadsheets, which a lot of your data will be in, or data in databases, which again, a lot of your data will be in, can easily be exported to a comma-separated value or CSV format. Now, I expect probably most, if not all of you, are familiar with CSV files, but just in case you're not, a CSV format basically is just a way of structuring a file such that values are separated by commas. So here's an example of a CSV format. We may have one line that says the name of someone, followed by a comma, followed by their age, followed by a comma, followed by their location, followed by a comma, and then a new line representing a new record, their name, followed by a comma, their age, followed by a comma, their location, followed by a comma, etc., etc. So if you're all used to using Excel, you can, for example, in Excel, you can export any spreadsheet as a CSV file. And what it'll do is it'll break down your columns this way and your rows this way, so that each row will contain the value from the first column, followed by a comma, followed by the value from the second column, followed by a comma from the third column, etc. And you can see already that's going to be a useful way in which we can deal with our data. What you don't want to be doing really is to be reading in raw Excel files. Excel files come with all sorts of utter nonsense that's packed in there. You want it down to its raw, purest form, and the way you do that is by, in many cases, by using a CSV file, which will contain just the data you need, comma separated. So how do we read and write CSV files? Well, there's actually a library called CSV that allows us to do this really easily. So one way is you can use the method I showed you a minute ago of reading in files in that way, but there's a better way, and we use the CSV library. So if we import the CSV library in our code, then what we can do, let's say I've got a file name called filename.csv. I'm going to open that in read-only mode. So I'm going to say with open filename.csv in read-only mode as F. Now everything in this body of the with statement is now keeping that file open, and I can refer to it as F. What I can do with the CSV library is I can set up something called a reader, and that object will then read. I can call functions on that reader that will allow me to easily read in bits from a CSV file. So I declare a new reader. I say reader equals csv.reader. So it's a reader from the CSV library. And then I pass two arguments to that. I pass in the file that I want the reader to work on, which remember we've called F, and the delimiter. And the delimiter in most comma separated value files will be a comma, but of course you can have other delimiters. So some files may be separated by semicolons, for example. Most of the time though, it'll be a comma. So most of the time, that exact line of code will be exactly what you need in your to read in your file. So we've now told it we've got a reader, and it's a CSV reader, and it's going to act on file F. And that file is structured such the delimiter, the things that are separating the values, are commas. So now I can say, let's imagine that I've got the example I had here, where I've got each row has a name, followed by a comma, followed by an age, followed by a comma, followed by a location, followed by a comma. And let's say what I want to do is to store in my program, I want to read in that information, and then I want to store the list of names in one list. I want a list of ages in the second list, and I want a list of locations in a third list. And I can do that really easily using the CSV reader. So I can send within the reader is separated into rows, which represent the lines in our CSV file. So I can just use a for loop to say for row in reader, for each row in my reader, which remember is the read in CSV file, I want you to my list of names, append the first value. So row represents the line. If I then specify an index of 0, that means the first value before you got to a comma. Similarly, an index of 1 would represent the second value after a comma, and row 2 would represent the third value. So you're separating out. So here, this would be row 0, this would be row 1, and this would be row 2. And then in the next row, this would be row with an index 0, this would be row with an index of 1, this would be a row with an index of 2. And you can see by doing that, I'm going through each row, and then in my 3 lists, list of names, ages, and locations, I can then add each value. And if I run that, you'll see that then in my list of ages, I've got 3 ages, I've got 3 locations in my list of locations, and in my list of names, I've got my 3 names, and then I can work with those things more sensibly. I can also do the same when I'm writing CSV files. And again, you're probably going to want to write your model results as a CSV file, because then it becomes much easier to work with however you want to analyze it. So let's imagine we've got a couple of lists that we want to write. Let's imagine we've got a list of Pencordian names and a list of numbers associated. So imagine the Pencordian names are almost column headers, and the list of numbers are various numbers associated with those Pencordians. And let's imagine I want to write this to file. What I can do, I can combine both of those lists into one big list and have a list of lists. So here I've got a list of lists which contains the list of Pencordians and the list of numbers. And then I'm going to start writing. So again, I use my with open statement. This time though, my file is output.csv, and I want to write. And I want to write in such a way that if something already exists for that file name, I want you to overwrite it and start again. So I'm going to open it in W mode. And again, we're referring to it with the alias F. So now I can refer to this opened file as F. Remember, if output.csv doesn't exist, it will now create it because we've put it into write mode. Like we did before with the reader, the first thing we're going to do is create a writer object. So we say writer is a csv.writer. And again, exactly the same input. So we need to give it the file, which is F, and the delimiter, the way in which we want the file to be structured, which again is going to be comma. And again, most of the time, that's how you're going to want your file set up. So you can pretty much copy and paste that line of code every time you want to write to a file. And then for each row within our list of lists, we want to write that as a row in our file. So what I can do is to say, so the first row is going to be our list of Pencordians. And then the second row, we want our list of numbers. So I can say for sublist and list of lists, so in our list of lists, we've got the list of Pencordians followed by the list of numbers. So I can say, first of all, for the sublist in list of lists, so the first thing it'll go to is the list of Pencordians, which is this list here. And then I can just say writer.writeRow, and I pass it a list, which is this list here. So just by saying writer.writeRow and then giving it a list, it'll automatically then write that list as a comma separated list. And then it'll go to the next list in our sublist, which is the list of numbers, which is here. We pass that into writeRow, and it'll write this as a list. And so both of these things will then be, if we looked at this in a raw, something like Notepad, for example, or text editor, then we'd see a list file that said Alison, Andy, Dan, Kerry, Martin, etc. And then on the next line, 1, 2, 3, 4, which is what we want. And of course, if we could open that in something like Excel, and Excel will then interpret that and open that back up as a list of columns and rows. Okay, any questions about any of that? No? Okay, so what I want you to do is to practice having a go at reading and writing files. Now, you've been given a file called input_data.csv. So that's hopefully you've downloaded that. That's on the Slack channel or the GitHub repository if not. So you'll need to make sure that file is stored wherever you're going to store your program. So I'd advise you using Spider for this particular exercise. That input data.csv contains a data set of fabricated patient data. And the data contains a number of patient records, and each record consists of the patient's first name, their gender, their age, and the county in which they live. So let's have a look at the file. So I'm going to open it in a spreadsheet here, but you can see, so it's automatically said number of records, mean age, number in Cornwall, number in Devon, number in Somerset, percentage male, percentage. Oh, no, sorry, that's the wrong one. Oh, that one, isn't it? No, it's not that one either. Input data. It's in here, that's why. Sorry, it would help if I open the right file. There we go, that's the one. So this is the file you should have. You should have a load of names with their genders and with their ages and with their locations. Now, if I was to open that as a raw file rather than in a spreadsheet, if I open that with a text editor, you can see how the comma separated value file is actually structured. So each line followed by with a number of entries with commas separating each of those entries. So what I want you to do is to write a program that does the following. That first of all reads in that patient data file and stores the 4 different fields in 4 different lists. So you want a list of names, a list of their genders, a list of ages, and a list of counties. Then I want you to get the program to calculate the number of patient records that are being read in and print a message to the user that informs them how many records have been read. I want you to then get it to calculate the average age of patients in the data and print a message to the user informing them of the average age, rounded to 2 decimal places. I will show you how to do that in a moment. I want you to calculate how many patients live in each of the 3 counties. So how many live in Devon, how many live in Cornwall, how many live in Somerset, and display the results. I want you to then calculate the percentage split between male and female patients in the data and display that result to the user, again rounded to 2 decimal places. And then write the results of 2 to 5 above, so all of these things up here, write those results to a file called results.csv, where the first row is indicating the name of the result. So that's your column heading. So your first one would be number of records read in, then it would be average age, for example. And then on the second row would be the actual result. So the actual number of records, the average age, etc., that you've calculated up above. Now, in order to do this, you'll need to know a couple of extra things which I haven't shown you yet. And these are here. Just as a little shortcut, I probably should have shown you this at the start, but I mean like that. I wanted to get you used to using loops. So there is a function which some of you have already found called sum. And if you pass an iterable object, something like a list, into sum, it'll automatically add up all the numbers within that list. And I bet you wish you had that this morning. There's also a function called round, which takes 2 inputs. And basically what round does is it rounds a number to a given number of decimal places. So the first input we give it is the number. And then the second input is how many decimal places we want it to. So if I give it 3.147 and I want that rounded to 1 decimal place, I'd give it 3.147 and then comma and then 1 here, and it will return that number as a number rounded to 1 decimal place. So using those 2 extra pieces of information, those 2 functions, you should be able to now complete the exercise using that information. Now, we've overrun slightly, so I'm going to give you a bit of time to do this. You may want to work in groups, you may want to work individually. It's entirely up to you. If you're struggling a bit, you may prefer to work in a group, and that's absolutely fine too. We're going to break for lunch at 12:30. I'm going to come back at 1:30 with the solutions to this. So you've got 25 minutes now before lunch, and if you want to work into a little bit of lunch, that's absolutely fine too. If you want a bit more time on that, as I say, we'll be floating around if you need any help. But to have a go at doing this, but do make sure you do take a lunch break as well. Any questions about that exercise? No? Great. Okay. Have a go at that. As I say, maybe tackle it in your team, see what you can do, um, and we will come back with a solution on the Zoom call at 1:30, and we'll run through that before we go into this afternoon session. So have a stab at that, and remember to break this down. So think about all of the things it's asking you to do. Refer back to your notes on reading and writing. But do make sure that wherever you're saving your file, your program file, your .py file, make sure it's in the same folder as wherever you've got your input data.csv file. That's very important. It needs to look for it in the same file. Okay, great. Shout if you need help. Otherwise, have a go at that, and I'll see you all at 1:30. Fantastic.